Good day, students. We are now in week 5, grade 9 science lesson. So before we proceed, I am Ruzzel Gracie Carbajal, your science teacher. So our topic for today is all about heat and work. So before we have your heat and work topic, let's check this video. So what are the uses of heat? Okay, so based from the video, what are the uses of heat? We have the following uh, daily chores that we have. First is cooking. Second is ironing the clothes. Third is drying the clothes. So first, for the cooking, that is in your topic for grade 7 and 8. It is related with conduction. So those are the properties of heat or the heat transfer that we have in your topic in grade 8 and grade 7. So, first is conduction, since it has direct contact with heat through your oil. Second is your ironing of clothes. So, we have your flat iron as a source for conduction. And third is radiation. Why is it radiation? Since for drying of clothes, the source is the sun. So the heat waves falls into the earth and then dries our clothes. So before we proceed, we have objectives. We have three objectives. Letter A is demonstrate what heat can do work. B, demonstrate how heat causes internal energy of water to increase. And C, solve important problems regarding changes in the internal energy of systems, base energy added to the systems, and work done by the systems. So under induct part, we have the instruction, identify the related word presented in each slide. Use these symbols to reveal the terms to consider. So based from the four pictures that we have, what term is related into it? So that is heat. So heat refers to the form of energy that is transferred between systems or objects with different temperatures. Next one, we have your different parts from the brain, the organs, from machines. So the word related to it is, oh, there is a plus. And then we have the symbol of energy. So we have internal energy. So internal energy is the sum of all kinetic and potential energies of the atoms molecules in the system. Next term. That is from workout, we have work, a measure of energy transfer that occurs when an object is moved towards the direction of force applied on it. Next picture is, since they use thermal, so that is thermal energy is the other term used refer to your internal energy. So we have your different kinds of thermometer. So an instrument used to measure how hot or cold something is. Next, so it is related to thermometer. So that is temperature, the average kinetic energy of atoms and molecules in a system measured by a thermometer. Next one, we have your nutrition facts. So you have your food, your daily intake calories. So we are referring to your calorie, the amount of heat needed to raise the temperature of a gram of water by 1 degree Celsius. So we have Mr. Prescott and boiling one. So we have the word joule, a unit of energy named after the physicist who experimentally determined the mechanical work needed to produce a given amount of heat. Next, so we have hot to cold. Amount of heat is based on mass and temperature. We have cold beverage and then your bulb. So it refers to thermodynamics. This is study of heat and its transformation to other forms of energy. So here we have melted ice cream, your heat balance, your temperature homeostasis, and then your food that is adiabatic. It is a process wherein there is no gain or loss of heat. So what is heat? Let's refer to this video.
Heat energy. Everyone probably knows something about heat. We often use the word to describe something that feels hot when we touch it, or to describe a hot day. To fully understand what heat is, we first have to understand something about energy. Energy has to do with the movement of the particles that make up matter. If we were to look up close at the particles of something very cold, we would see them moving very slowly. If their movement is very slow, they have less energy than the particles that make up something that is hot. For example, particles of hot water in a pot would vibrate very quickly, so they would contain lots of energy. Heat is actually a form of energy that is being transferred from a substance at a higher temperature to another substance or substances at a lower temperature. Have you ever touched a hot pot that was on a stove? What happens when you touch it? It burns your hand because the heat energy is transferring from the hot pot to your hand. Your hand had a different temperature than the hot pot. Your hand was much cooler than the hot pot. Heat energy always travels from a hotter substance to the colder substance. In this case, it travels from the pot to your hand. Think about what happens to a mug of coffee when you pour hot coffee into it. The mug felt cool at first, but then felt hotter as you poured the hot coffee into it. The hot coffee transferred its heat energy to the mug, which was cooler. Heat is not the same as temperature. Have you ever used a thermometer to measure something's temperature? Temperature is a measure of the energy that matter contains, or how hot or cold it is. So, when you use a thermometer, you are measuring how fast or slow the particles in matter are moving. The faster the movement of the particles in an object, the higher the temperature of the object will be. Heat, once again, is the transfer of an object's energy to another object with a lower temperature. Heat energy is something that is very useful to all living things. In fact, no life would be possible on our planet without the light and heat energy from the sun. The sun makes it possible for all plants to grow. Plants, in turn, are needed by living things to consume. When we're in our homes or schools, we use heaters. These heaters heat the air right above them and eventually transfer this heat energy to the rest of the air in the room. This works in a way quite similar to how an oven transfers its heat to a bowl of liquid kept in it. The hot bowl transfers its heat energy to the liquid being heated. Toasters and coffee makers are two other sources of heat energy found in our homes. Can you think of any other source of heat energy? A fire of any kind is a source of heat energy. If you go camping, a fire will provide a nice source of heat energy on a cold night. A gas stove has a flame that is the source of heat for warming things up. Our own bodies produce heat. You can tell this by holding a piece of ice. After a few minutes, the heat energy from your body is transferred to the ice, causing it to melt. A bathtub that is filled with hot water can transfer its heat energy to a person who needs to be warmed up. Heat energy can be used for many things. The most obvious is for keeping us warm in our homes and cooking food on our stove. As mentioned before, a hot bath can be used to warm up our bodies. Heat energy is also used by plants to make food for themselves. In some places, there are hot sources of water found deep within the earth. These can be used as a source of electricity. When hot water is used to make electricity, this is called geothermal energy. Here is the summary of the lesson.
So we have heat energy always travels from a hotter substance to a colder substance. For example, when we touch a hot pot, the heat energy transfers from the hot pot to our hand, which is cold. This is why it burns our hand. So temperature also tells us how hot or cold a substance is. You use a thermometer to measure the temperature of a substance. Heat energy is very useful to all living beings. Plants use light and heat energy of the sun to grow and make food. animals eat these plants. Other sources of heat energy are heater, gas stove, fire, and hot water bath. We use heat energy for cooking food, to warm ourselves in winters, and to make electricity. So, all in all, your heat energy is related with our other kinds of
Heat
energy.
energy.
So, how can we identify the mechanical equivalent of heat? So, the proponent is the English physicist, which is Sir James Prescott Joule in 1845. He experimentally determined the mechanical work needed to produce a given amount of heat. So, this mechanical equivalent of heat is almost all the work done formed into heat using this device. He found out that 4.194 joule is equivalent to 1 calorie. A calorie is a unit of energy that is equivalent to amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius, ideally measured from 14.5 degree Celsius to 15.5 degree Celsius. So this is the mechanical equivalent of heat by Sir Prescott Joule. So we will use this scale in converting units in our thermodynamics later on. So 1 calorie is equal to 4.186 joules. 1 kilocalorie is equal to 1,000 calories. And 1 British thermal unit is equal to 252 calories. So if you're familiar with the word calorie, it is related with our food. So whenever we intake food, we have a specific calorie in that food. So heat and internal energy, that is related with your conservation of energy, where energy cannot be created nor destroyed. It is also related to the first law of thermodynamics. The change in the internal energy of a system equals the difference between the heat taken in by the system and the work done by the system. So, for example, we have this machine. So, this machine will not work if there is no heat. So, the law is expressed as delta U is equal to Q minus W, where Q is equal to the amount of heat flowing into a system during a given process. W is the net work done by the system, and delta U, the change in the system's internal energy. So we mostly use these units. So one is your joule, which is your mechanical energy can produce heat and that they are related to each other. And your calorie is the amount of heat needed to raise the temperature of a gram of water by 1 degree Celsius. So we have your sample problem. This is related with your first thermodynamics. If 150 joule of energy is added to a system that does not apply external work, by how much the thermal energy of the system raised? So based from the problem, we have the following given. Your Q, what is Q? That is the amount of heat flowing in a system during a process. So that is 150 joules. While since we have 0 joules, because it does not apply external work. So what is W? That is the net work done by the system. So let's find your delta U. So the solution is 150 joule minus 0 joule. Your delta U is 150 joules. So there is no change of uh, internal energy coming from a system since it does not apply the external work. So we have the following concept to consider. The increase in the internal energy of a system is equal to the amount of heat added to a system minus the work done by the system. It tells us that systems energy can be changed by transferring energy by either work, heat, or a combination of the two. Facts to consider: heat is energy transferred due to temperature difference. Substances heat or cool as a result of energy transfer. Heat transfers from warmer bodies or your higher temperature to cooler ones, lower temperature until both reach the same temperature. For example, we have your ice cream. So it melts since the environment is, if it is sunny, it always melts. We have the following sample problem always melts. We have the following sample problem. So let's check it out. So if we have 35 joule of energy is added to a system that is applied, 10 joule external work, by how much the thermal energy of the system raised? We have the following given: Q is equal to 35 joule and W is equal to 10 joule. So we need to identify your delta U. So we have the following solution. Delta U is equal to Q minus W. Just need to subtract it, and then you have 25 joule. We have also 120 joule of energy is added to a system that does 80 joule of external work. By how much thermal energy of the system is raised? So we have the following given: Q is equal to 320 joule and W is equal to 80 joule. So you need to find your delta U. So you need to subtract it, and then you'll get 240 joules. Another sample problem: 240 joules. Another sample problem: if a system has 7.2 calorie of heat added to it and thus 20 joule of work, what is the change in its internal energy? So given is Q is equal to 7.2 calorie, you need to convert it to joules. So we have 30.14 joules. W is 20 joules. You need to find your delta U. So your new Q, you need to use that 30.14 joule minus 20 joule, that is 10.14 joule. The last one, about 750 calorie of heat is added to a system that does 42 joule of work. What is the change in the system's internal energy in calories? So given is Q is equal to 750 calorie, W is 42 joule, convert it to calorie, that is 10.03 calorie. Find the delta U. You just need to subtract it, and your delta U is 739.97 calorie. Before we check your assessment, let's have your Kahoot game pin. That is 05782842. Okay, so we are now in your Kahoot game. So that is our game pin. Let's enter. So we have, let's join the game. There's no change in the internal energy of a system if there is no work done. Answer is true. Okay, next. The flow of heat transfer is from cold to hot. That is false. Next. Substances that heat or cools are the result of energy transfer. Yes, that is true. The unit of energy is Newton. That is false. Particles that vibrate very quickly contain low energy. That is false. Thermodynamics is the study of work and its transformation to other forms of energy. That is true. Kernel is a product of molecular kinetic potential energy and other kinds of molecular energy. That is true. 1 calorie is equal to 4.186 joule. That is true. Next. Energy can be created nor destroyed. That is false because energy cannot be created nor destroyed. And the last one, heat can do work. Obviously, that is true. So that is our Kahoot game for your assessment. So save the link and come back to see the podium once the challenge has finished. And for your assignment instruction, answer the following in a 1.5 sheet of paper. Form a to-do list plan on what activities you've done before work and what food did you eat. This will track your internal energy if it increases or decreases based on the work and get done by the body. So that ends our lesson for today. Thank you and have a nice day.